So my name is Thomas, and today I'll be trying to introduce you to the GNU Autotools, if that is a possible challenge that you accept. So I work for Electrons. We do embedded Linux consulting and training. I do work on the kernel, especially on the support for certain families of ARM processors. And I also work on build-root, which probably some of you have heard from 2 hours ago. I had a discussion with one of my colleagues, build-root versus open embedded, the Octo project. And it's by my work on build-root, working on cross-compiling and adjusting the build system of numerous existing open source projects that I got to learn some aspects of the Autotools that I wanted to share today. So when talking about the Autotools, most people think, die, Autotools, die, die, die. But it is actually a German book. So it's the GNU Autotools. It's not die. So no one has ever yet written a book about getting the Autotools to die, but there are still books that teach you the Autotools, including in German. So why the Autotools? So yes, they are old. Yes, they have their pain points. Yes, people hate them. But due to this, people tend to kind of roll their own build system. And those roll their own build system, they're actually worse than the Autotools by most means. I know a lot of projects, I don't know, FFmpeg or maybe QEMU and other projects that have rolled their own build systems, and they are really a pain to work with, actually much more painful than the Autotools are, because the Autotools bring a number of benefits that are standardized, and they're also not that complicated when you take the time to take a step back, look at the basics, look at a simple project that is done with the Autotools. So the benefits of using the Autotools is pretty much standardization. You get a standardized build procedure and behavior. So you know what to expect. If you run make, if you run make dist, if you run make check, if you run make install, you know what's going to happen. You know that this specific variable or this specific configuration option is going to have this behavior because it's standardized in the build system. It has proper support for things like diverted installation, which is crucial for cross-compilation. It's the ability to say, build as if the thing is going to be in /user, but don't actually install in /user, but in some other location, which is needed for cross-compilation. Or even for proper packaging, like Debian packaging uses that as well. They install to a temporary location, they package that into a deb package, which in the end is going to install in /user, but that's not actually the location where it was installed, where make install the things. It has built-in support for out-of-tree build, which allows to have like 3, 4, 5 different build directories for the same source code, which are very often handwritten or roll your own build system don't have. It has proper handling for dependencies between source file and header files. They are automatically computed. They have support for some aspects of cross-compilation. It's somewhat esoteric, but the languages used are kind of standardized ones. So once you learn them, like Makefiles and shell script and so on, it's useful for numerous projects. And the number of projects using the Autotools is still quite large today. So if you spend the time to learn the Autotools, it's going to be beneficial for many, many projects. Of course, there are alternatives like CMake, for example, which is growing in popularity, and it's very good. I have absolutely nothing against CMake. It's just that still today, a lot of Unix tools, libraries, and utilities, and packages in general use the Autotools, so it's for sure you'll come across them at some point in your embedded Linux journey. So first of all, I'm not an Autotools expert at all. I grew up this limited knowledge by working progressively on the build system of various components, as I said. I don't know the internals of the Autotools. I only use them, so I have a purely like user perspective on them. And this tutorial will really only cover the basics. But at least from my perspective, when you have to face a technology that looks complicated, because if you look at existing configure script, existing Makefile that are designed to work with Automake, they're like, wow, that is really, really complicated. I don't understand it's happening. And by going back to the basics, starting from scratch, building up from that, at least from my perspective, it's easier to progressively understand what's going on and be able to understand and tackle more complex cases. So I'm not going to cover all the complex cases that you can imagine handling with Autoconf, Automake, but really talk about the basic things, what are the essential mechanisms that you have to understand to be able to get your head around the build system of other packages. And I believe that what I will give is enough to be able to understand the Autoconf and Automake reference documentation so that you can actually start from them there after having had this discussion. So we're going to have 5 steps in this kind of tutorial. First, we'll have a fairly quick user point of view. It's not like I'm writing something that uses the Autoconf or Automake and the Autotools. I'm just using something that already uses that. And then we're going to have some discussion on the basics of Autoconf, the basics of Automake, and then we're going to continue that with some basics of some more advanced topics on Autoconf and some more advanced topics on Automake. So when I say advanced, is advanced as opposed to the really, really basic things. We're not going to cover very advanced aspects of those tools. And I have also no idea how much time it's going to take, so maybe we'll have to end before the full set of slides. I really don't know. Of course, if you have questions, feel free to fire them during the tutorial, make that interactive. That is very welcome. So the user point of view. So I guess if any in the room, and I guess it's probably the case for most of you, have already used any software component that use the Autotools, you know the /configure, make, install, dance. So we first run a shell script that looks at the available build environment, checks a number of dependencies, and generates make files and other artifacts that are needed for the build. Then the build actually runs based on the make files that were generated by configure. So it builds program libraries, several of them, and other things as described in your make files. And finally, the installation. That's pretty much the basic usage of the Autotools. So configure takes a number of template files that end in .in, processes them, and does some variable replacements that we will cover later, and generates from that the final files, which are the same name without the .in extension. So it generates makefiles from makefile.in. It generates config.h from config.h.in, and possibly other files as needed by doing this variable replacement. So that's pretty much the output in terms of files. Of course, beyond generating those files, it's before that doing a lot of checks on your system, verifying that you have this library installed, this function available, this header file available, and so on and so forth, as we're going to discuss later in this tutorial. It provides standard makefile targets. That's, as I said, one of the benefits of working with the Autotools. You don't have to look at the makefile itself. You know it's going to offer all those standard targets, and they will have a standardized behavior. So I'm not going to go through each of them. They are well documented, but make install, make clean, and make this clean, and so on and so forth. The Autotools is kind of compliant with the file system hierarchy standard. So it's defines a number of variables that are named here, prefix, exec prefix, bindir, libdir, includedir, and so on and so forth, which are the standard location according to the file system hierarchy standard where the different things should be installed. This is the place for binaries, this is the place for libraries, this is the place for documentation, for headers, etc., etc., etc. And it complies with that. And each of those variables is available internally in the Autoconf Automake logic, but also available as an option of the configure script. So you can adjust them. And again, this is going to be the case for every project that uses Autoconf Automake, and that's one of the key benefits of those tools. Same thing, standardized config variable. You know that every configure script is going to understand this set of variables and actually many more, which allows you to override the compiler to use, the C++ compiler to use, to add some more flags, and so on and so forth. And you know it's always going to work. And trust me, the handwritten make files or handwritten configure scripts always get it wrong, always, all the time. So at least with the Autotools, you get a behavior that is going to work. The Autotools also work pretty well for cross-compilation. There are sometimes some issues here and there, but generally speaking, that's a concept that they handle relatively well. And they identify 3 system types: the build system, the host system, and the target system. The build system is where you're on the build. The host system is where the software you're building is going to actually run. And the target is something that's only used for a very limited number of programs that are generating code for another platform. So if you are building a cross-compiler, for example, your build machine is, well, probably your PC. Your host machine is also your PC because you want the compiler to run on your PC, but the target is going to be, I don't know, ARM or MIPS or PowerPC or whatever platform you're using. However, when you are cross-compiling, you're building on your PC, for example, BusyBox that you want to run on your embedded system, and then the host is going to be your embedded system. And all of those three system types are by default automatically guessed by Autoconf, the configure script, but you can override them by passing --build, --os, --target. So this is what allows to basically switch the configure script into a cross-compilation mode. So I'm going to give a quick demo over here. So I've extracted the source code of Kmode 22. So I hope it's clearly visible here. It's not very practical. The resolution is not terrible, but it will do with it. So we have a typical Automake-based project here. It has a configure script, configure.ac, config.h.in, Makefile.am, Makefile.in, and so on and so forth. I guess all of you are used to doing like configure. It checks the environment, checks whatever needs to be verified. From that, I now have a Makefile that has been generated, which I can use to actually build the project. And that's pretty much it. If I want to do cross-compilation now, let's illustrate at the same time that I can do out-of-tree build. So I simply do something like this. And it's like this. So I say I want to target ARM, for example. I'm doing this. So it says, hey, your source directory is already configured. So it wants, when you do out-of-tree build, to have the source directory completely clean. But you can do several build directories. So I'm going to run that again. And that's pretty much it. So as you can see here, it summarizes, hey, I'm going to use that compiler. So it looks like it's working pretty well. Doing the build. And hopefully, if I go there and do that, I have an ARM binary available. So the cross-compilation, as I said, by default, the configure script will guess those three system types, but by overriding --host, you can tell it, I'm cross-compiling. And actually, by default, the value you use for --host is used as the prefix for the cross-compilation toolchain. So you can optionally override that by using CC and CXS and LD and R and so on and so forth. But here, because I specified ARM-Linux-GNU API HF, it uses that as the prefix for the cross-compiler, the cross-linker, and so on and so forth. And that's how it cross-compiles. You can do out-of-tree build, as I demonstrated. So by default, you generally do in-tree build, but out-of-tree build is also super cool because it allows to build multiple different configurations of the same software without rebuilding from scratch each time. So that's really, really nice. It also avoids cluttering the source tree with object files and build-related files in general. So that's exactly what I demonstrated before. Diverted installation. So as I said before, one of the benefits of the Autotools that's kind of built-in. So by default, when you do make install, it installs in the directories that are specified by --, prefix. So default value for --, prefix is /user/local, but you can override that to /user or whatever location you want. So when you run make install, it's going to install in this location, which is fine when you do native compilation and installation, but when you do cross-compilation or packaging, as I mentioned, you want to divert the installation. So you want the build to be exactly the same, but at the installation step, instead of installing to the exact location where the software will be running from, you install in a different place. So that's what you can do with the dest-dir variable. So you can do a dest-dir demo foo install. And so I can show that everything from this Kmode project has been installed in tmp demo foo, user include, user share man, user bin, and so on and so forth, user lib, and so on. So you can package that or use that as part of a build system that cross-compiles and throw it into my root file system. Yes, please. All right. Thank you. I'm just going to adjust that a little bit. Give me a second. I will manage to do it. I only have my touchpad here, which I'm really bad with. So if I do this, it should be a little better. You don't need the top of the screen anyway. Better? All right. So dash prefix or desdir is exactly what I covered. If you do, some people kind of confuse the two things. If you do dash prefix equals /home, blah, blah, rootfs, something, and then you package that up and put it in your embedded system, then at runtime, your application will probably try to load icons or data files or other files from /home, blah, blah, rootfs, something, which doesn't exist on your target. So prefix is really the location where things will be executing from, while desdir allows to temporarily override where it should be installed. So directed installation is really key for proper cross-compilation, as part of other things, but it's one of the key things. So you've got typically different use cases. When you're doing native compilation and you want to install things system-wide, you're going to do configure prefix /user make and sudo make install so that it installs in your system-wide. Probably not nice because you're like workarounding your package management system, but you can still do it. You can also install in a user-specific directory, and that's where a custom dash prefix comes into play. Say dash prefix home foo /sys, for example, then make install. You don't have to be root because that's all installed as a normal user. And then your application or library is available from home foo sys user bin user lib and so on and so forth, and you can use it on your machine from that location. Or you're cross-compiling, and in that case, the configuration is like the first step. You configure so that it's gonna be run from /user, but an installation time, like I've just shown for the Kmod example, you divert the installation to some other directory that you will package up as your root file system later on. Autoconf very conveniently leaves behind itself a file called config.log that traces pretty much all of the tests it's doing and storing the result of those tests. And it's typically where you want to look for first if you have some configure issues, like it fails with some unexplicit error message. That's really the key place to look for more inputs. So it contains several sections: platform core tests, running config status, cache variables, output variables, confdet.h. But annoyingly, it's not really like a log, because towards the end of the file, you get a dump of all the variables, which is interesting, but it's not the most useful part. So usually you want to scroll up a little bit and see actually the results of the test themselves, which is the running config status step, if I remember correctly. So in that case, that would be like, if I go from the bottom here, I have conf.h, and then the variables themselves here as well. And here is actually the result of all the tests that it is doing. So it's even before the core tests part. So that's the interesting part. In that case, it wasn't failing, so there's nothing really fancy to look at, but that's really where you can get more details about what happened during the configure step. So the Autotools, how do they are organized from a high-level point of view? So the configure script is a shell script that gets generated from configure.ac by a program that's called Autoconf. In some other project, you can find it named configure.in, which was the old name, but it's now deprecated, and it's recommended to name it configure.ac, to not confuse it with other .in files that are processed in a completely different way. So the configure.ac is written essentially in shell script, even though it doesn't really look like a shell script, but it's augmented with a large number of M4 macros that allow you to describe the test that you want to run. The makefile.in are generated from Makefile.am using a program called Automake. And those Makefile.am are pure make syntax, so they're actually valid make files, but they wouldn't really mean a lot to make it directly. Instead, they use special make variables that are expanded in standard make constructs to describe the build of your programs and libraries and documentation and so on and so forth. But it's actually a valid make file on its own. There are some auxiliary tools like AutoHeader, AC local, and so on, but it's more like the internal plumbing that, as I said, as a normal user of the Autotools, you don't usually need to be worried about. Autoconf, Automake are your primary entry points. The generated files, so if you look at a configure script or a makefile.in or a makefile generated by Autoconf, Automake, it's really horrible. I mean, it's like thousands and tens of thousands of lines of shell script or complicated make code, but you shouldn't be reading them. And what you should be reading instead is the source itself, so configure.ac or Makefile.am. But to be able to read them, it means to have some limited understanding of what's going on. And that's kind of the point of this tutorial, to hopefully give you this minimal understanding that will help you understand the real source instead of trying to figure out what the damn 20,000 lines shell script is doing, which no way you can understand. So you should really see like the configure script, makefile.in, makefile as almost like binary stuff. I mean, you wouldn't open up an ELF file in Vim to understand what's going on, right? You would look up the source code for it. So it's pretty much the same for the Autotools, I would say. Really go back to the real source itself, which is, yes, written in that weird language, but at least it's somewhat understandable. So the overall organization is something like that. And if you've always been confused by all of those files that are around, it's probably the first big picture to remember here. So the developer is only writing the pieces in yellow at the top. Configure.ac and one or several Makefile.am. So there's usually only one configure script per project. There are exceptions, but that's kind of the typical rule. But there might be as many Makefile.am as you want. And we'll discuss that a bit later. So that's really the only thing that the developer writes. Configure.ac gets processed by two programs. Autoconf to generate a shell script that's called configure, which is kind of the main visible thing that you get. It's also processed by autoheader to generate a template of a header file, which is named config.h.in. So this is a header file in the sense that it is going to be potentially included in C code or C++ code. But it's not yet the final version because we don't know yet what will be the configuration in which we will be at the moment of the build. So it's just a template. On the other side, for each makefile.am, Automake generates one makefile.in, which is like almost the final makefile, but not quite yet, because we don't, for example, know which compiler we will be using. We don't yet know in which configuration we will be running, if we will be cross-compiling or not, if this optional library will be available or not, that kind of thing. So it's really just a template. And then when you run configure, it takes those green files and generates the final versions for them after running the detection and configuration tests. So typically from a distribution point of view, if your software is coming directly from a version control system, you would get only the files in yellow because you don't version control generated files most of the time. However, if you get a tarball release, usually you would get both the yellow files and the green files together in the tarball. The red files are obviously generated at build time, so it doesn't make sense to provide them as part of the tarball release. All right? That makes sense? Another thing that's useful to know as a user of the Autoconf is that each test is normally, when it's a well-written test, associated to what we call a cache variable. So a cache variable is a variable that basically stores the result of the test that says, yes, this library has been found, or no, it hasn't been found. Yes, this header file has been found or not. And it stores that. And the idea is that you can use such a cache to speed up further follow-up execution of the configure script. That instead of doing the test again, it just says, oh, it's in the cache that the library was available or the header file was available, and doesn't do it again. On my side, I don't really care about this speed-up aspect, but the other thing is that you can feed up those variables on the configure command line to tell configure, don't do this test, assume this value. And this is sometimes important when you're for cross-compiling. There are some tests when they are written in a custom way that are not cross-compiler friendly. So you need to tell the configure script, assume this library is available, or assume the location of this program is there, or assume this or that. And if you pass those variables on the configure command line, like is shown here for the pass to sed, then it's going to skip the test and simply assume the value you pass is correct. So it's sometimes pretty handy to solve cross-compilation issues. So as I said, from a distribution point of view, if you get a tarball, usually Autoconf, Automake has already been executed, and you already have a shell script that's very portable. It should be. It's normally a POSIX shell script, so it should run pretty much on any system. You should already have the makefile.in, which will be processed by the configure script, generate the final makefile, and then you can build. However, if it comes from a version control system, and it's actually more and more the case that projects get shipped simply on GitHub with a tag, and so you don't have any pre-generated configure script and Makefile.am, and in that case, you have to run them by yourself. So of course, do not version control those generated files, because depending on the version of Autoconf, Automake you use, they're going to be quite significantly different. So that's going to generate a lot of patch noise, which is very useless. So to regenerate those Autotools files, you could call like Automake, Autoconf, AC local, AutoHeader in the right order. I would honestly not be able to do that properly. So there is a kind of higher level tool that's called AutoReconf that automates that process for you. You just do AutoReconf and it does AC local and AutoHeader and Automake and everything that's needed. There's a useful option, -I, which asks AutoReconf to copy into the project some auxiliary tools or files that are needed for the build to proceed. But that's pretty much all you need to do. AutoReconf -I is your like one common way of regenerating all those files. Any questions so far? Are we good? Yeah? All right. So let's get into the Autoconf basics. So the configure script, which is generated from configure.ac, it's actually a shell script, even configure.ac itself. So you can write any arbitrary shell command into the configure.ac script. It's going to be copied as is in the final configure script, right? But of course, if it was only a shell script, we wouldn't generate it. We would just write it directly. So it's in fact processed through the M4 preprocessor. And the point of Autoconf is actually to provide a fairly significant set of predefined M4 macros to more easily write tests that will check for the availability of header files of functions, provide the capabilities of providing options like -- enable something, -- with something, and so on and so forth. In addition to providing those high-level constructs, which we will discuss later on, it also provides some fairly basic constructs that kind of wrap the normal shell constructs. For example, you got AS-if or AS-case that replace the if, then, phi, or case, exact constructs of the shell. The reason why it provides those constructs is for portability. One of the original reasons to have Autoconf Automake is portability across Unixes, which may still be important in some situations, but has become less important than it used to be maybe than 20 years ago. Still, those constructs are available. In practice, what I see is that a lot of people are using directly shell constructs for test and case and for all those basic things because most shells happen to support them properly. But if you do a construct that is like, for example, bash specific, then it's only going to work, your final configure script is only going to work on bash capable systems, where sh is linked to bash, which is not all systems. So normally, if you want to write a really proper configure.ac file, you should be using all those wrappers. But most of the tests will actually not be written manually. You will have higher level M4 macros, which we'll discuss to perform those tests. The quoting mechanism in M4 is using square brackets. So you'll see that most of the time, if you want to be safe with the arguments that you pass to macros, you need to enclose them between square brackets. So that's one part of the reason why those files look so funky. I mean, it's not very usual to use square brackets to enclose arguments, but well, that's the way it works. So yeah, in this tutorial, I'm not going to say what's good or bad about the Autotools. I'm just going to say how it works. And yeah, maybe some things look weird or bad or could be done better. Yeah, for sure, but that's how it is today. So the minimal configure.ac is 2 lines. So that's why I said I'd like to come back from scratch. So that's something that will actually generate a configure script. So we got AC in it, which must be called by every configure script. That's the beginning, as the name suggests. It takes 2 mandatory arguments, the name of the package and the version, and you can pass a few other arguments that you can see here. And it must be like the kind of the first line of any configure script. And at the end of the configure script, you need to have AC output, because this is actually what asks to generate and run config.status, which is an auxiliary script generated by configure to actually run the tests themselves. And this config.status is what will generate the make files and other files that result from the configuration. So if I get back to my demo thing around here, let's go there, we'll check out demo 01, clean everything, all the mess that I might have having. So I have a project that is just AC init, AC output. I can do autoconf-i. It's gonna do, so is it clearly visible for everyone? Yeah. It generates just a configure script. I can run it. It tests nothing because there's nothing to be tested. And that's pretty much what happens. I have config.log and that's it. So that's from the beginning, right? That was the first demo. Then there are some additional macros that you can use, like AC prereq to say, I want at least this version of Autoconf if you're using some features that are only available starting from a certain version. You have AC config source dir, which tells Autoconf the name of one source file in your tree, which should exist, otherwise configure will not run. Or AC config auxdir, which we'll use a bit later, to tell Autoconf, okay, all those sorry, auxiliary files that you generate or that you copy, instead of putting them in the middle of my project, put them in some subdirectory to keep things cleaner. That's something we'll use a bit later, but still I can show you. So I should have a second demo around here. So it's more or less the same, except I've added an AC prereq and AC config source dir. I'm going to do the autoreconf, and you say, hey, you need the autorecon 2.70 or higher, which I don't have, and which I think is not even released. I intentionally put a way too high version number here to make it fail. All right, so it generates fine, but it's, hey, you're looking for, I'm supposed to be running a project that has at least one file called hello.c, so you can run it, and it does nothing more than it used to do. So it's pretty much just some additional macros. They are not super useful on their own, but very often used. Then you have some additional tests. So you could write a piece of shell script that would try to check for a compiler, a C compiler or a C++ compiler or awk or grep or whatever. But if you do that by yourself, you will probably get it wrong. It will work on your system, but probably not on the systems of others. So for those high-level checks that are very common, Autoconf comes with its own macros to help you. So AC proc.cc will try to find an available C compiler and store its path in the CC variable, make sure it is at least minimally working, and so on and so forth. AC proc.cxx would do the same for a C++ compiler, and you get it for the other variables here. So let's continue our journey here. Yeah, clean. All right. Yeah, I want to go to this guy. Okay. So I've got pretty much the same as before, but I've added this AC proc.cc thing, and I still have for now this empty file. So if I autoreconf it, run configure, you see it's doing this time a few more checks. So instead of doing no checks at all, it's checking if I have a compiler, whether it works, what's the default output file, and so on and so forth. Those are all the things that Autoconf thinks it needs to know to be able to build C stuff. Again, I'm not going to comment on whether it is smart to do so many checks, but it's what it does. Then another construct that is this time a lot more important to understand in Autoconf is AC config files. AC config files is a macro that takes a list of files, and this list of files will be processed at the time of AC output by doing a replacement of a number of variables in those files. So what it will do, it will take any of those files, append a .in extension, take the .in version, like file.in, generate file from it after having done the replacement. Right, so it's typically used to turn the Makefile templates makefile.in into the final Makefile. So that's how configure script replaces or generates the Makefile from the Makefile.in. But it can also be used to generate other files, like config.h or other things. So these, the variables that will be replaced are labeled as @variable@ in the .in files. So whenever in a Makefile.in or in anything.in, you see @something@, the configure script will replace that by the value of that variable. And there is a long list of standard variables that will be replaced by Autoconf. For example, if you have defined the AC proc cc macro, it will automatically replace @cc@, which is the path to the compiler, with the right path to the compiler. But you can also ask Autoconf to replace additional variables using the construct called AC subst. So AC subst, as written here, which are 3 equivalent ways of saying the same thing, it says, anytime you see @foo@ in a .in file, replace it with value 42. So that's the way there is, I would say, communication between the tests done in the configure script and the files that are generated by the configure script. Be they Makefile, they can be PKG, description file, they can be documentation, they can be whatever you want. Really, configure is completely agnostic from what type of file it is processing. It's just replacing those @variable@ construct. So we'll have the usual short demo, demo 4. So here I have a configure.ac that does only a replacement on a file called test file. As you can see, there's AC config files, test file. This test file looks like this. So it's not a make file, it's nothing, it's just something that allows us to illustrate what's going to happen. All right. So now I'm going to run configure, and it generates the final test file. So as you can see, it has replaced apps build dir, which was here, by the correct value. @foo@, well, it's still, @foo@, wasn't replaced, and cc is gcc. All right, so those two standards, apps build dir variable and cc variable, were replaced, but not foo. If I go ahead in here and do AC subst foo 42, and I run again Autoconf, I'm going to do it this way. Okay, configure again. This time around, as you can guess, foo gets replaced by 42. So that's the primary mechanism that allows Autoconf to adjust the generated files, right? Work so far? Okay. As I said earlier, it's possible to configure.ac is really just a shell script, so you can include whatever shell constructs you want in there. Beware to not use bashism, but well, if you do, it will only work if your default shell is bash. So most configure scripts, as I was saying, use directly shell constructs, but normally you're supposed to use those AS echo, AS if, AS case wrappers instead of doing things directly. But still, to illustrate that, we have this other demo. So let's see what I want to illustrate here. So as you can see, we're gonna simply echo the value of cc before AC proc cc. We're gonna echo afterwards. We want to test the value of foo and define it if it's not defined, and then subst it, which is another illustration of what we've done before. So if I run this, I see first the value of cc is nothing, and after all the tests done by Autoconf, it's as a value. So this is really to illustrate fundamentally it's a shell script. Yes, AC proc cc ends up expanded into a huge amount of shell script, but it's just shell script, nothing else. Then in test file, foo has been substituted to 42, but if I pass something like this, I guess it will be substituted by that, because my little test is, if it's not defined, then I define it to some value. All right? That makes sense? I think I had another demo here. I don't remember exactly what I wanted to illustrate, but we'll figure out. Yeah, so this is a better variant of the same thing here, where I've used ASIF, ASEcho. It's going to do exactly the same, but it's using the more correct wrappers provided by the Autoconf. But again, in practice, in real life, I see most of the configure.ac script using directly some basic shell constructs. So at this point, you actually have enough to check for a compiler, and that's enough for a very basic program or a very basic library. Of course, we'll see a lot more tests afterwards, but that's enough for the moment. So at this point, we are able to generate a final Makefile, for example, from a Makefile.in. But just like writing a configure script from scratch is super complicated if you want to do it right, it's the same for writing Makefiles. So that's why we have Automake. So you won't write Makefile.in manually, but you will write Makefile.am, which will, as we've seen before, generate Makefile.in that will be processed by configure to generate the final Makefile. So I hope first that kind of explains why we have this two-step process for the Makefile, where we have the real source file .am that gets processed into a .in, which itself gets processed into the final Makefile. Are we all right so far? Let me check the time. Okay. So the basics of Automake. Very much like configure.ac is by itself a shell script that is like processed to generate the shell script. Makefile.am are themselves written in Make language, but they are processed to generate a Makefile that is actually more useful. So it's augmented, it's the Makefile standard that gets augmented with Automake specific constructs that are expanded into like normal Make code with targets, dependencies, and running commands, and so on and so forth. So for most situations, the Automake constructs are sufficient to express what you need to build, if you need to build a program, a library, some documentation, and so on. But it's possible to also override that with your own make rules and things like that. That's not a situation we're going to cover, where we stay in the like normal conventional case, but it's possible to go beyond what Automake provides. So a minimal example of Automake, Makefile.am, is something like that, where you say, I want to build a program that will be built as a file called hello that will be installed in bindir, so that's why it's bin programs. And then this program is built out of the following source files, just main.c. So that will build main.c to main.o, and then, sorry, that there's a typo here, main.o into the hello executable, and install that into prefix/bin. So that's sufficient to express the build of a simple program in its installation. It will make sure it cross-compiles fine, and so on and so forth. So even for simple programs or simple projects with a 10 lines configure.ac and a 4 to 5 lines makefile.am, you can get the job done. And it actually works a lot better than a handwritten Makefile because it does cross-compilation, divergent installation, out-of-tree build, make dist, all those things are working out of the box. So to allow usage of Automake, you need to do a few steps in your configure.ac. First, you need to have a call to am init Automake. That's kind of what initializes the Automake machinery at the Autoconf level. And then you need, of course, to make sure that your makefile.in gets processed by your configure script by using AC config files that we've covered before. Of course, if you have several makefiles in subdirectories, you need to list all of them here. So that's the first demo we're going to have here. So let's see, we'll clean up everything. So what we have is just a configure script that looks pretty much like we've seen. We have a simple makefile.am here. We're going to do autorecon.i. So as you can see in the project, from a source code point of view, the noise is really limited. I mean, there's just one configure.ac, one makefile.am, not much more. Once you generate things, there's a little bit more noise, as you can see here. As you can see, our makefile.in was generated over here. It runs, it generates the final makefile, and I can build, it builds my program. Here I can do divergent installation if I want. It just works, I can cross-compile it. All those basic features are supported out of the box. So the am init automake macro, which we've seen, takes a few options. Some of them are quite complicated, and I won't cover all of them, but there are a few ones which are quite useful. First of all, the foreign option is nice. all this Autoconf, Automake comes from the GNU project, and the GNU project has its own coding style documentation, where they say every project should have a news file, a README file, author files, and changelog and whatnot, which I believe are quite annoying. You may not want to have all of those files in your project. So by saying foreign, you say, I'm not GNU thing, let me do what I want. So it's just gonna not annoy you with those files. If you don't use foreign, if you don't have a README, authors, new changelog, and so on, it's gonna abort the configuration of your project. You can also specify which tarball format should be generated by makedist. So that's another cool thing. If you use the Autotools, you run makedist, and bam, you have a release tarball that is available, and you just have to upload it. And you're sure that this release tarball is actually usable by people. So you can select here the compression type you want. That's not super important, but it's there as well. Subdir objects is more interesting. It comes down to whether you use recursive make or not, which is something we'll cover a little bit later. So I'll get back to Subdir objects later. And then you can specify the minimal version of Automake that you accept. So it's kind of the same as AC prereq, which was for Autoconf, but this time for Automake. So let's kind of dive a little bit into those just two lines. Because an Automake Makefile is actually composed on one side of product list variables. So those are variables that list the things that you want to build. And then they contain product source variables, which define what is the source file that you will use to build those products. So if you look closely here, the name of the product is hello. And so the name of the product source variable for hello is the name of the product itself underscore source. And then can be other types of product source, other types of products themselves. But that's the general constructs. So for product list, the syntax is always, could be a modifier, which is optional. So in that case, we don't have any modifier. The prefix, so in that case, it's bin, which means the result of this product will be installed in bindir. So if you have like include underscore programs, which doesn't make a lot of sense, but you could do it, it would install the program in /user/include, and so on and so forth for the different directories, standard directories that Autoconf understands, right? So that's the prefix part. And then the primary is the type of thing you're building. Whether you're building a program, whether you're building a library, a libtool capable library, whether it's just publicly available headers or just arbitrary data or Python script or documentation or et cetera, there is a certain list of standard product types that Automake understands, which you need to use as the primary. And then, as I said, after the equal sign, you have the list of products. So if you want to build multiple programs, you can say bin programs equal blah, 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 et cetera, et cetera. Is that all right? That's really the base constructs in Automake. The second one is the product source variable, as I've said. So it's the name of the product underscore source. So I think there's only one primary in that case. And the product is the string that you've used in the previous variable. There are some tricks here, like if the product name has some weird characters that are not valid in make variables, as make variable names, then they are replaced by underscores. Like if you have foo.out, for example, as a product variable, the corresponding product source variable will be foo underscore out underscore sources, because dot is not allowed in a make variable name. This variable will contain the list of files that are needed for the product to build. And this includes both the source files themselves, but also the header files. If you forget to include the header files in there, whenever you're going to run makedist, Automake is not aware that you have those files in your source tree, so it will not include them into the release tarball. So really you want to list all the files that are involved into building that program or that library or that other thing that you're building. So let's have a look at the next demo. It's kind of a surprise even to me, all the demo, because I've done them some time ago. I don't quite remember all what they do, but we'll figure out. So here is, a slightly more complicated case. The configure.ac is not more complicated, still the same. In Makefile.am, this time around, I've done some kind of poor man a really poor type of like translation, and since I'm French, it's going to be hello and bonjour, which means hello in French. So we're building two programs, hello and bonjour, and we say for each program what files we're using. So hello.c, say.c, command.h, and same thing for the n. And we even have some documentation here. So if I do autoreconf.i, same deal. I can do configure. Okay, it generates all the usual files. It has generated both the hello program and the bonjour program, which is the same in French. And if I install all of these into, for example, tmp hello, you can see that it has installed both programs, but also this README file directly in the documentation folder, because I said, yeah, that's just, README is just documentation, it's normal data. So data says, that's just arbitrary data, copy it where it should be. And doc is docdir, which is user shared doc, because that's the default location for documentation. All right? So that's how you decide where things should go, what should be built, and so on and so forth. So as you can see, the basic constructs are really, really simple. Any questions so far? No? I see we're losing gradually some people, so there must be something odd. Yeah, please, sir. Yeah, so part of the modifiers, you have the nodist modifier, which allows to tell you this file should not be part of the release tarball for some reason. It is there in my source tree, but I don't know, for example, it's part of your version control source code, but you generate some code out of it, and only this generated code is part of your release tarball for some reason, but not the original source, then you can mark it nodist. This way it's not in the release tarball.
How about in the other case where it's the file outside of your source tree and you want to distribute it?
Which is outside the repository, you want to distribute it. I guess you can always put like some relative path or something, but I'm not sure how to handle that case. Yeah.
Like if it was redistributing a dependency, it's not a common dependency.
So in that case, either you really ship both separately, like it's a library and a program, and it's two separate packages, and you need to build that one first and this other one next. Or you can also have this mechanism where you have nested Autoconf Automake projects. So you have your own project, which needs a dependency that's not very commonly available. So you can include into your source code the entire source code for that dependency, and ask the top-level configure script to start to run the nested configure script of that project, run the build in a nested way, and so on and so forth. It's not super nice, I find, but it works. And some projects do it. Like if you look at something like GCC, it does that. It has like one top-level configure script, one top-level makefile, and it has sub-configure scripts for the different sub-projects in it. And a number of other big projects are working like this, which makes them even more complicated to understand from a build point of view, but yeah, that's how they work. Other questions? Okay. So let's look a little bit more at Autoconf details. Configuration header is an important thing. So very often when you're writing C code or C++ code, you need to know some results of the configure step. Like you need to know, is this function available? Because if it's available, you will use it, and if not, maybe you will fall back to some other solution. Or you need to know, is this library available? Like I don't know, if OpenSSL is available, I'm maybe going to allow you to use encryption or authentication or something like that, and I will have this code implemented in my C program or C library. If not, I'm going to fall back into a mode where I don't provide encryption. So you need to know the results of those tests from a C point of view. So very much like AC subst is the way that Autoconf uses to communicate the results of tests to make the processing of Makefiles. The configuration header is the mechanism that you use to communicate from the results of the configure script to your C or C++ code, or even possibly other types of code. So in your configure.ac, if you write something like AC config headers, and again between square bracket config.h, Then at the moment of running Autoconf, it will also run a program called AutoHeader that will generate a template called config.h.in that contains something like not like this because that's the final one, but basically the results, but commented out. That's just a template. And when you will run configure, it will actually do the checks, and for each of those entries, we'll replace with either a comment or by defining the value. And that will be the final config.h. So that's something you can see here. And the idea is that this config.h being generated by the configure script, your C source code can sharp include it and use the macros to actually decide what it should do or not do. So let's have a look at that. I think the demo is afterwards. So is that clear? So most of the built-in tests in Autoconf are going to write something to the to config.h. You can, if you're writing your own custom test in the configure script, the way you can add things into the configure header, the config.h header, is by using AC define. So if you do AC define foobar 42, it's basically going to end up sharp define foobar 42 in config.h. So be careful to not confuse AC subst, AC define. They don't substitute or propagate values in the same thing. AC subst is for the .in to something generation, while AC define is really for the config header. So that's where I have the next demo around here. Don't have any other. Check out demo 08. So in here, so pretty much the same, except I have this AC config headers, config.h, and I can do autoreconf. All right. So now, as the result of doing autoreconf, I have this template, which for the moment doesn't contain anything really useful. If I run the configure script, it not only generates the Makefile and all that sort of things, which we've already mentioned, but also the final config.h, which has been replaced with proper C defines that I can use in my program. So you can do something like this, build, and if I look in there, no, it's not there. It's probably in this file. Yeah, I'm using like package string, which is defined by config.h. And as you can see, it's going to work and say the version of the program. Yeah. That's a silly example, of course. It's just showing how it works from that point. Is that OK? Maybe I should just show, did I write something in README? No. So let's see what happens if I do AC define something like my example shows. Something like this. Right. So in the templated version, I have this. So that's just the .in. If I run configure, and I look at that one file, as you can see, it's defined to the value of define as expected. So of course, defining just AC define unconditionally like this is completely useless. But the point is that if you write, and we'll see how to do that a bit later, a custom autoconf test, you will want to let your program or library know what was the result, and one way of doing that is using AC define. Then there are autoconf macros to check a number of things. We already saw AC proxy C to check for a C compiler or for a C++ compiler and so on and so forth. There is a family of function AC func to check for a number of well-known functions. When they exist, usually they don't not only check that the function exists, but that it works as expected. Or if it's just a certain function that doesn't have a specific AC func macro, a dedicated one, you have AC check func or check funcs. You give it either a function or a list of functions, and it's going to verify that those functions are available. So the way it does that is pretty simple. It generates a very small C program, tries to build it and link it, and if it links, it assumes that the function exists. That's the way internally Autoconf does it. And the construct is for those macros is pretty much always the same. You say as first argument what you want to check, And then you have two arguments to say what should be done if I find it or if I don't find it. But for most of those macros, it's already doing some default behavior without doing nothing special. It defines a variable called AC CV func, the name of the function, that you can use in your configure.ac script to maybe do something more like, hey, if this function is not available, let's check if I have this library, for example, to replace that function or that kind of logic. And it also defines a have name of the function definition in the configuration header. Yep.
Is there a similar thing for checking for a custom program?
Yes, yes. That's pretty much here. AC check progs is going to be what you're looking for if you want to check for a program. So here it's checking, hey, I'm looking for a program that whose path will be stored in a variable called Perl. And it might be named per file, it might be named Perl, and it's going to try to find in the path where it's located. All right, so let's move on to this. Yep. So for the inclusion of config.h, either you do it manually in your source files, in which case you have to do it in all your source files, or you can add directly to the compiler flags something like -include config.h, in which case the compiler would automatically enforce that the config.h is included in all the files. So that's also possible. It's not done by default. That's why I've shown kind of the default way here. But you can add a compiler flag saying, please always include config.h before processing the file. It's more a preprocessor flag than a compiler flag, but I guess you get the point. Which maybe CMake is doing automatically. I don't know, but it's not the case here. Yeah. Okay, so we're at demo 9. So, yeah. So this is just checking for two functions, printf and foobar. So as you can expect, one of them is going to exist and not the other one. So you see it's checking for printf and foobar. It's in the config.h, we then have printf, but have foobar is not defined, as you can expect. And I'm going to show you that you can actually overwrite the results, which is completely silly because it's not going to work. But as you can see, I passed ACCV func foobar equal yes. So I'm pre-feeding the result of that test and say, hey, it's cached. I'm already telling that this function exists. So I'm going to pretend it exists because you told me so. And indeed, here it's going to be defined, which is silly in that case, but allows in every situation to override the result of an autoconf test if you're not happy with the auto-detected value. So there are similar macros to check for headers. Yep, please. So AC check func is only checking in the standard library. Then there are other macros that I'm going to show to search into other libraries. But this is only... Yeah, that's what AC search libs and things like that that I'm going to comment on are made for. So we have things to check for headers. As you can see, it's pretty much the same. Check for one header or several headers. They define a variable and then a definition in the config.h header. So that's, again, pretty much what I was saying at the beginning. Once you get the general feeling of how those macros work, you look up the reference manual for Autoconf. Pretty much you have this description in a much more detailed way, and you can figure out what it is doing, what it means, what the terminology means. So here is an example. Hey, does spawn.h exist? Yes, no. It's pretty much the same as AC check func. So checking for libraries, AC search libs is there. So you give a function, you give a list of libraries to search for, and it's going to try in sequence those libraries. So it's first going to try with no library at all, in case maybe it's available in the C library, And if not, it's gonna iterate over the list of libraries that you give to find, well, hopefully the one that has the function you're looking for. And it also, you can pass additional libraries in the last argument, other libraries, like if your library has some dependency and you need all together to actually make the test successful and find the function, then you can feed them at that point. Yep.
Can you put snippets of shell script in this actually file?
Yeah, it is shell. Yeah, you can even like nest them. Well, I probably wouldn't nest them, but I would rather like use the ACCV search variable after calling AC search lib and see if it's no, then maybe I want to check somewhere else rather than nesting, which will be a bit nasty. But yeah, this is what you have in action if found or action if not found is really just shell code. So here is another example. Demo 10. I'm not sure until what time we have exactly, but we'll figure out. So what? Clean. I don't remember which demo I want to do on that one, but this is just checking for the same libraries. Am I using something more? Yeah, I remember. So here I'm using dlopen. So I want to know whether I need to link with libdl or not. So what I'm going to do, I'm just going to do an AC search, and I never remember the name, libs. So it's going to be dlopen, and I will search in libdl, something like this, hopefully. Yeah. So it checks for the library that contains dlopen, and it concludes that I indeed need to link with LDL to have it working. And so when I do so, it actually links my program with it, which works as expected. So without much effort, it does things automatically. So if a library is found, it automatically prepends it to a variable called libs, which is used at the link time to link your programs. So that's all automatic. There are other checks. I won't go in the details on all of them because once you've understood the idea for function checks and header checks, it's pretty much the same to check for programs, for declaration, for structure members, for types, and so on and so forth. There are lots and lots of already available Autoconf checks. The more interesting things is that you can write your own tests, which is essentially those macros are the ones that are used internally to write the test that we've just covered. So AC check functs and so on and so forth, they use those macros. So you can ask Autoconf to either pre-process or compile or link a certain input to decide whether a given feature is available or not, or a given feature is broken or not on the system. So this input should be some C code, and there are some macros available to format it and make sure it's properly coded. AC lang source and AC lang program. So it's actually all those macros that make those configure.ac somewhat unreadable. But well, once again, once you get to it, you can understand what's going on. You can also write runtime tests using AC run if else. But runtime tests are really nasty because they are run on the machine that runs the build, which is perfectly fine if you're doing native compilation. But if you're doing cross compilation, if you make some conclusions like, hey, let's look at what's the endianness of the system, and it's like little endian, and your target is actually big endian, fail. Let's look at what's the bitness of the system. Oh, it's a 64-bit laptop. I'm going to assume 64 bits, but your target is 32 bits, fail, and so on and so forth. And there are actually lots and lots of programs who do this. They do like, is there like let's look at /proc version to see if the kernel is recent enough. Yeah, but the kernel on my laptop has nothing to do with the kernel I'm running on my embedded system. So those runtime tests, those are the ones that cause usually the most number of problems when cross-compiling. And it's not inherently Autoconf that is broken by design, but rather the person who has written the configure script who did things incorrectly. So here is another demo. I never remember. So what do I have around here? So here I just wanted to check some random function, well, not random, but some see if my compiler supports sync, fetch, and add. So I'm just wrote a very short snippet here. Yay, do you have this compiler intrinsic available? And it's just gonna do that test for us, so which we don't see because we're just trying to build that thing. I think I'm not even sure we're gonna see it in the log because here we see it in the log. And it says, so that's a good way of looking in the good opportunity to look in the logs. We see in the logs, so it tried to build a program that looks like this. So it generates a file that has all those definitions, and then simply my snippet of C code there. It tries to build, and it sees that, hey, I'm complaining that uint 8t is not defined, which I think I can quickly solve by doing something like this. That's pretty much all it needs. So if I run it now, I should hopefully get something that works better. So no longer have any message about this function failing. Since my test is very simple, I don't see anything in the output. We're going to cover that soon. But it did the test and apparently was successful in checking that function. So that's really the simple way of testing a certain feature of your compiler, of the availability of a function, whatever. Or the availability of a function in a certain library or a certain construct in a program, whatever you need. You can print messages with those macros. I won't spend too much time on them, but AC message checking is going to just print, hey, I'm currently checking for that feature, and then AC message results is going to say yes, no, or found in this. So it's the typical prints. There are other things you can use, like AC message error, which will abort the execution of the script with a message or a warning, or that kind of things. So you can probably continue on that thing. I'm not sure. Let's see. What did I propose to do? I can probably do something like this. Yeah, it's probably good. Let's do this. So before, I'm gonna do that, and then I'm quite lazy, so I will do something like this. Yeah, that's cool. It's gonna actually show. Should be hopefully fine. We'll see that. Yeah. Ah, no. Yeah, that should be fine, right? Well, I won't spend too much time on. Maybe this constructs its. What am I missing here? Let's just use a real text editor and figure that out from the, something like this. Should normally link fine, so I hope. Yeah, so I don't know what paste was. Let's keep this around. So this is a slightly more complete test because now it's going to show the message and then yes if I found it and no if I didn't. And it's also doing a definition in the header file. So it's showing there was a question whether I can put a shell construct in here. Yes, it's actually a shell construct. I'm printing something, then I have a semicolon, and then I'm doing something else. So if I run this, I have this. I'm checking for blah, 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 blah. Yes, I can find it. And in the config.h header, I can find my definition. So I've written a new Autoconf test. Then you have cache variables, which I've mentioned earlier, allow it to speed up the subsequent configurations, but also to override the results, which is not possible with the tests I've written so far. It's going to redo it all the time, and you can't override it, which isn't that nice. So you can use AC cache val or AC cache check to do that. They're pretty much the same, except that AC cache check is going to automatically write the message, I'm checking for this, yes or no. That's pretty much the only difference. So if I further continue my demo here, and I replace that with something like this, I can do this. So it's an even more complete version of it. So what I'm doing here is that I'm saying, okay, you will check for this feature. That's a human readable string. That's the name of the cache variable. That's the same program I was using until now. If it's successful, then I define the variable to yes. Otherwise, I define it to no. That's kind of one of the tricks with AC cache check, is that in the actions, you're not allowed to have side effects other than setting the value for the cache variable. And so whatever I want to do, depending on the outcome of this test, is done outside of AC cache check. So I'm doing like, hey, if it's been set to yes, then I'm doing the config.h definition. So I can do again autoconf-i, configure. So the test still works. I still have sync 1 byte funcs defined to 1, but now I'm able to do something like this to force it to no, and you can see cached, it assumes no. If I look in the config header, it's undefined, right? So we've written from scratch a short autoconf test that combines AC link if else and AC check val around it to print a message and support the cache variable mechanism. Then you have the probably more famous, more well-known mechanisms to support the with, without, and enable, disable options that are commonly passed to every configure script, ./configure -- enable debug or whatever. AC arg with allows to create a pair of with without options, and AC arg enable allows to create a pair of enable disable options. They are pretty much the same. It's only really in their usual usage that they differ. Normally, the with without are used to indicate whether you want to use external software or not, while enable disable are more used to define whether you want to enable some specific internal feature of the software you're currently building. So maybe with OpenSSL, without OpenSSL, but enable debug, disable debug, or enable that feature, disable that feature. But technically speaking, you can use whichever one you want for whichever purpose, because all what they do is you define a name for the option, which is going to be with and that name, some help string, and some actions that will be executed if the option is given or not given. And here there's a little trick. Action is given is not you have enabled the option, and action is if not given is you have not enabled the option. Action if given is executed if some value is given, either whether it's enabled or disabled, and action if not given is executed when no value was passed at all, neither enabling, explicit enabling, or explicit disabling, right? Inside those snippets, and well, in action given actually, the value that was passed, so the argument is available in a variable called withval. So in this short shell snippet, you can use withval to set whatever variable you want. And outside of this macro, a variable will be defined, which is called with and the name of the package. So for example, with _ OpenSSL will be whatever the conclusion, the value concluded by this macro was. So AC arg enable works very much the same way, same usage, same arguments, same everything. The only difference is that the variables will be named enable val inside action if given, and enable _ and the name of the feature outside. That's the only thing, the only difference between the two. There are also helper macros to help you format the help string to make them align nicely, the with option and the description and enable option and the description that you're probably used to in a help output. So there's AS help string to help you do that. So we'll have a look at that thing right now. Again, anybody knows what time I'm supposed to stop? Sorry? 6 o'clock. Oh, that leaves half an hour still. That's probably not going to go all the way to the end, but it's so here is a quick demo. It says I'm going to define a -- enable debug -- disable debug option, And when it's given, I'm just going to show the value, enable val, and if not given, I'm going to just show this message, and then I show whatever value was concluded. So that's pretty much. So in -- help, we can see my option in there. If I run, well, value was not given, indeed, it wasn't. Enable debug is nothing. If I do enable debug this time around, the value given is yes, and enable debug is yes. And as you can imagine, value given is no, and enable debug is no, right? So as you can see, there are actually three situations here. Explicitly enabled, explicitly disabled, and, well, not decided at all, in which case it's up to the configure script to decide what it wants to do, what is the default value for it. Yeah, so I could do something like this in the configure.ac.
So how does your regular if then? Is that risky, or I've seen some recommendations to use the macro for if tests?
Yeah, so in practice, as I've said, in practice, if test something is, I think it's POSIX compliant. So in practice, it's going to work in pretty much all shells you can find. Maybe some old weird AIX or HPUX or something will not take it, but most of the configure script that I've seen use directly the shell construct. It's not technically correct if you read the Autoconf documentation, but the practice shows otherwise. So here I'm just taking the output of the test and saying, well, if it's actually enabled, then let's have a definition in the config.h header. So I can do that. Right. Then you make config.h. I have debug enabled, which is 1, so anything in my C code can test that and do whatever it wants with it. All right. Another thing that is very useful is a pkg config. So it's kind of a separate tool from Autoconf. It's actually separate, but it's, in my opinion, a much better option, a much better solution to find libraries than AC search libs for a number of reasons. So pkg config is a simple tool that looks up in a database of text files that use a .pc extension that each describe a library installed in your system. So normally most modern libraries, when you install them, they install their shared object and maybe statically linked libraries and documentation and so on and so forth. But they also installed in user_lib/pkg_config one file that ends with .pc, and that describes how other libraries or other programs that want to link against that libraries, what they should use in terms of compiler flags and linker flags. And due to that, it's much nicer than SC search libs because you're not trying to like guess what should be done, but instead you just ask the library, let me know how I'm supposed to be linked against you. And you could directly use the pkg config command line tool, but in practice there is a very nice Autoconf macro called pkg check modules that does all of that for you. So it's in fact even simpler to use than AC search libs. So here is how it works. pkg check modules, you can say the prefix is just like an identifier of the libraries you're checking for, and it will be the name that identifies the prefix C flags and prefix libs variable that are generated by this macro. So unlike AC search libs that directly adds the libraries to the global libs variable so that everything is linked against it, here in pkg check modules is just put that in some variables, which you can use in your Makefile.am, right? Then the second argument, list of modules, is the list of pkg libraries, so essentially the list of .pc files that describe the libraries you want to link against. And then you have the usual action if found, action if not found thing, which is very similar from, one Autoconf macro to the other. By default, pkg check modules will simply bail out with an error if any of the dependencies is missing. So it's that's a mandatory dependency kind of thing. So here is a short demo as usual. Let's check out my demo 13. We're gonna get configure.ac. I probably want to use, let me see what I had in mind. Oh yeah. So my code is now using the curl library. It's just doing one function call just to illustrate what's going on. So I want to do this, I build, and bang, it fails because undefined reference, because I'm not linking against it. So I can do AC, so PKG check modules. Curl, something like this. So maybe it's not named curl. I don't remember what's the name of the thing. Well, let's see. I have a cheat file. It's named libcurl. All right. So now it will actually check for curl here. So if I grab something like this, it shows that curl libs is now set to -l curl, which should work, but it doesn't, because I need to change my Makefile.am to make that happen. And that's something we'll see a little bit later. But at least we see that from a configuration point of view, it has found my library, it has found the flags that are needed, and so on and so forth. Another tool that I personally rarely use, but some people use, is Autoscan. It scans your source code. Yeah, I've got your question. It scans your source code and tells you the things that it uses that you should be checking for. So it generates a template configure.ac that you can use as a basis, or it verifies if your existing configure.ac is checking for all the functions it should check, all the headers it should check, and so on and so forth. I personally don't use it that much, but it can be seen as useful. Yes, please. Yeah, absolutely. Absolutely. It is part of your packages. So if I just, let me just get that up here. So I'm not an RPM guy, but I guess you will pardon me. It's, I think, that one thing. So, yeah. So the .pc file gets installed as part of the development files for the library. So whenever you install your -devel or -dev, package, it's part of it, next to the headers and documentation and all. And it's just really simple. Just a text file that says, hey, I'm libcurl, I'm version of this, here are the flags you need to use, and so on and so on. There's one thing that is actually really convenient, is the libs.private field. That's kind of going a little bit in the details here. But when you do dynamic linking, you just need to link against curl. So you do -l curl, and that's it. Even if curl itself is linked against many other libraries, because the shared object files describes which libraries curl itself is linked with. So when you're doing dynamic linking, it's all easy and fine. But when you're doing static linking, it's much more complicated, because a .a archive doesn't have any information about the dependencies it has. And in that case, if the object files in this archive depend on other libraries, then you have to actually know it. So if curl depends on like IDN or RTMP or netel or something like that, you have to pass all those arguments on the command line to make your program statically link. While here in pkgconfig, you can ask pkgconfig where you can tell whether you're doing dynamic linking or static linking. If you're doing dynamic linking, it's going to return you this. If you're doing static linking, it's going to return you the combination of this and that, because this is also needed when static linking. So that's another benefit of using pkgconfig, but that's kind of a side thing.
What generates that file?
Sorry?
What generates that file?
Depends. It's normally upstream part of the upstream library. I mean, most modern libraries, they will have it, and very often it's generated. So you have a .pc.in that's written by the developer, and then at configure time, the final .pc that gets generated by the AC config files mechanism that we've seen. So it's Makefile.in are not the only files that get generated. This one also might get generated at configure time.
So there's nothing automatic that will generate this for a
No. At least not as far as I'm aware. So you can have additional M4 macros. So there's a set that is part of the core Autoconfs that are described in the Autoconf reference manual. But there is also additional ones, such as the one for pkg-config. They are actually not part of the core Autoconf. They are provided when you install pkg-config. There's a pkg.m4 file that gets installed that provides the pkg check modules macro and a bunch of others. And there is another project called the GNU Autoconf archive, which is a huge archive of macros to do other type of tests that were seen as not being sufficiently important to be in the core, but still useful to a number of people. So you can pick up those macros and integrate them in your project. So I had a demo on that thing, but since time is kind of flying now, I want to move on to other topics. I'm going to skip on that one for the moment and move on to more Automake related discussion. One thing we haven't touched yet with Automake is what happens when you have multiple directories. For now, we have just one or two source files, so everything is flat at the root directory of your project. So far, so good. But very soon, you'll want to organize that a little bit better with subdirectories. And you have, to handle that, you have two options. Kind of the traditional option, which is recursive make, and the more, I would say, modern and actually better option, which is non-recursive make. So recursive make is what happens when you call a submake to do the build of what's inside a subdirectory. In that case, you have one Makefile.am in every subdirectory, and the top-level Makefile.am just says, build what's in those subdirectories. And that can, of course, be done recursively as needed. But it's going to call another make invocation for each of them. Non-recursive make is what you do. If you do non-recursive make, you have a single Makefile.am at the top-level directory that describes the build of everything. Even if the source files are in subdirectories, in the top-level directory, you have this Makefile.am that says, I want to build this library, this program, this other program, this test, everything. The big benefit of non-recursive make is better parallelism, which is great since the number of cores is growing. Because when you do recursive make, it goes into a subdir, builds that subdir, and only then goes back and can build something in another subdirectory. It's not parallelized between directories. If you do a top-level, non-recursive make from the top-level directory, then make is aware of all the files that it has to build, all the dependencies between the files, and it can parallelize as much as possible, which is good when you have a lot of cores. So actually, recursive make is kind of considered harmful. There have been papers written on that, but today, I would say most of the old-style Autotools-based projects use recursive make, and only a few of the modern ones use non-recursive make. It's sad, but it's the way things are today. If you're really concerned about the non-recursive make causing a Makefile.am growing too large, nothing prevents you from using the include statement of make, which allows you to subdivide this Makefile.am in separate files, but still from the point of view of make, it's going to be a single Makefile that allows it to see all the dependencies between your files. So recursive make, going to cover, of course, both of them. It's going to look like this. So in configure.ac, instead of having just one file to process, you will have two or more makefiles, so makefile and src/makefile, maybe lib/makefile, and so on and so forth. Your top-level makefile.am is going to be maybe just subdirs equal src, which tells please recurse in the src subdirectory. And the src/makefile.am is going to be pretty much like we've seen until now. It can be as simple as that or grow more complicated as needed. Non-recursive make is going to require the am init automake arguments subdir objects. I've mentioned it before, and that's where it's useful. It tells Automake, it is fine if object files are generated in subdirectories, which is what's going to happen if you say, my program is built out of src/main.c. You want to tell Automake to build src/main.o in that very location, not in the top-level directory. Otherwise, if you have two main.c in two different subdirectories, the object files will collide up in the top-level directory. So in that case, you just have one makefile, as we had until now, and hello.sources simply reference the source file where it is. That's as simple as this. So, demo 14. Let's clean that up a bit. Configure.ac. I'm using this. Let's see, I wanted to show. Is it really demo 14? No, 16. Ah, yeah, I skipped up that one. My bad. Yeah, better. So now we have this subdir. We have the Makefile.am, which is just subdirs equal src. I still have my documentation in the top level directory, and my configure.ac. That has the two makefiles. Okay. Run that guy. Build, and as you can imagine, it builds in there, but you can see here, there's actually a submake that is executed inside the src directory. We see a second level of make. Well, if I go to my demo 16 and redo, so here I have this subdir object option. I have only one makefile that describes the whole thing, even though files are in subdirectories. Same dance. And here there's a single level of make. It's not doing a submake and building the different programs. So of course, for such a silly program, you're not going to see the performance difference, but as your library or program grows, the parallelism is going to be interesting. There are Automake conditionals, which allow you in a makefile to decide whether you want to build this file or pass those flags or things like that. So very much like, I would say, AC define is a way from your configure script to produce things that can be read in your C file. This is a way that your configure script can produce something that is usable from your makefile to make conditional compilation or conditional addition of flags or whatever you want. And the way to do it is simply am conditional, the name of the variable, and then some condition that, if evaluated to true, will mean that your make variable will be actually defined. Otherwise, it will not be. So that's typically an example, am conditional debug, which is defined if some condition is true. And in the Makefile.am, if debug is defined, then I can do this, otherwise I can do that. There's a little bit of a trick here. You cannot use conditional in make. You cannot use conditional inside the variable definition. So let's say if debug is enabled, you want to add an additional program to the build called baz. You cannot do what's on the left-hand side of the screen, like have the condition in the middle of bin program's definition. Instead, you should either do what's in the middle or on the right-hand side, which is have an intermediate variable that contains baz or may not contain it, depending on the value of debug, or simply use plus equal to append to bin programs if debug is enabled. So just a little side note on conditionals here. So let's have the demo 15th, which should show something like this. So we have this debug enabled thingy. And in Makefile.am, I'm actually going to build src/debug.c as part of the hello program only if debug is enabled. And this debug.c is simply a debug function that says something, but I'm kind of smart enough that if debug is not enabled, I have a demi function that does nothing to replace it, so I don't have to spread those if-defs all over the place. We can do Autoconf. Yeah, I do the build. So in that case, it seems to be a debug build. I don't remember if I enabled it by default. So yeah, here in the enable thing, what I did is that if not found, I say enable debug is yes, which means, yeah, by default, I want to enable debug. So I say hello, and the debug function gets called and say, this is the debug function. Very useful. It's actually really hard for such demos to come up with meaningful examples. So I didn't come up with meaningful example. I only have silly examples. Here I rebuild. It doesn't build debug.c into debug.o. And indeed, if I run it, I have no debug. So that's a demo of using am conditional. To build shared libraries, and that's another topic. So building shared libraries is very different between Unix variants. Building a shared library on Solaris and Linux and other Unixes is quite different. So the wrapper program has been created. It's called Libtool, which you tell, I want to link a shared library with those object files and produce this shared library. please do it. And it's actually it knows which compiler flags to use on which system to actually produce a shared library. It's, from my point of view at least, from the Autoconf, Automake, and pkgconfig set of tools, it's the worst of all. It's the one that is the most complicated to understand its internals and what it's doing and why it's decided to do that, but still that's kind of the default mechanism to do that. So it has a concept called Libtool libraries called .la, which doesn't tell you whether it's built as a shared library or the static library or both. It's just a library. And then depending on the configuration you give, it will enable either the building of a shared library or a static or both. And so there's a primary, Automake primary, just like we had programs or data or includes or that kind of things that is provided by Libtool. That's called LT libraries. So you can do lib_lib LT libraries, which says I want to build those things, those products as Libtool libraries. And it's typically used in conjunction with the headers primary to install the public headers. And to enable usage of Libtool, you need to call LT prereq and LT init in your configure.ac. So let's look at an example. So in your configure.ac, you add those two macros which initialize the Libtool machinery. And then in your Makefile.am, you're going to do something like this, lib LT libraries. So lib means it's going to be installed in libdir. LT libraries, it's a product that is a Libtool library. And here is the list of products I want to build. I want to build a Libtool library called libmyhello. It's going to be made of a single file called lib/core.c and a public header file lib/myhello.h. Since the prefix is include, it's going to be installed in include_dir, which is /user_include. Libtool also has a concept of versioning, which is kind of weird, but I guess you're used to having like SO.2.3.4. So Libtool has its own view of the versions, which I'm not going to go into details considering the time we have left, which essentially are not exactly the one you see in the generated files, but another way of versioning the libraries to account for whether your interface has changed in a compatible or incompatible way and that kind of things. And it automatically generates the symbolic links and the information inside the library in terms of versioning. I think I'm going to probably skip over that demo. I don't know what time I have left. Yeah, 6 minutes. I'm going to quickly skip over the demos for now and see if I have enough time left towards the end, because I'm almost done with the slides. Automake, you can also, and you sometimes need to define variables in your Makefile.am to affect the build, like if you want special compiler flags or link with some libraries or that kind of things. So you have the AM CPP flags, AMC flags, AM LD flags variables, which allow you to globally, in the build of that Makefile.am, adjust the preprocessor flags, the compiler flags, the linker flags. Don't use directly CPP flags or C flags or LD flags because those ones are passed from the environment. So if you set them in your Makefile.am, you will no longer allow the user to add more flags, more compiler flags, more linker flags. So that's why they have different names. LD add is to add additional Libtool libraries that you should link against. So here is a quick snippet coming from the glib project. It says, yeah, the stuff in that directory should be linked with libglib 2.0.la, which is built as part of the same project. And I want those other compiler flags and preprocessor flags to be used for the builds of the files in that described in that Makefile.am. And pretty much the same variables exist on a per product basis. So if you want this specific product to be linked against that library or this specific product to use those spatial flags for some reason, you can do it. So those are really the global ones and those are the per product ones. If you, one of the trick is that if you write one per product variable, it doesn't include the global one, it overrides them. So if you want to keep the value of the global variable, you need to include it again, which is what we see here. For example, module test LD add, I want to link against libgmodule 20.la, but I also need libglib itself, so I indicate again LD add in that case. So that's a per product variable, and here that's a global variable. This way, the module test program will be linked against both libgmodule and libglib. Make sense? There are also some pretty useful variables that are not you're not defining them, but they are provided by Autoconf in the Makefiles. Top srcdir, top buildir, and the same as absolute values, which I've used here. So if you need to reference something that is a product of the build, you have access to buildir or top buildir. So buildir is the same location as you are right now, but in the build directory. And top buildir is the top level directory of the build directory, and the same goes on for source directory. So depending on whether the path you refer to is some source code that is in your source tree, or depending on whether you're referring to something that is produced by the build, you will use one or the other. If you don't test out of tree build, you can very easily get it wrong, because when you do normal in tree build, source and build are the same thing. So you can potentially do mistakes here. Same, I will probably do that in a minute if I have some time. Another thing that is nice, but it's kind of a detail, but it's also nice to make things a little bit more shiny, silent rules. You can tell Automake, please don't show me all those GCC command lines. I just want something more silent. So you can enable AM silent rules, and you can say whether by default you want a verbose or non-verbose output, and it can do something like this, which looks pretty much like a kernel build for those who do kernel stuff, which is a little bit more nice to look at, I believe. And still you can pass v = 1 to get a full verbose build. Another thing that Automake provides that I've mentioned is building the release tarbles, make dist. So all the files that are source code or header files will be included in the tarball. But sometimes you need to include other things that are not really part of any product. So you can say with the extra dist variable, this file is there, please include it in the tarball. It's needed, you don't know why, but believe me, it's needed. And you can also say, I don't want this specific thing to be part of the distribution. For example, if it's automatically generated, which was the case here. If you have, for example, a header file that is generated at build time for some reason, it's going to be a source file for your build, but it's not necessary to include it in the release tarball. So you can also control these things, which are a little bit more subtle. Other things, the macro directory, it tells Autoconf, or more precisely AC local, to instead of creating a huge AC local.m4 that bundles all the macros that you're using, we'll put them in separate files in a subdirectory to make things a little bit nicer. So it's part of this thing that allows to remove a few annoying files that get around your source directory, which are a bit annoying. And the same thing for auxiliary directory. It's not the M4 macros, but auxiliary programs that the configure script needs. Instead of having them at the top level directory, you can say put them in build aux or whatever subdirectory you like to unclutter the build directory. All right, I guess it's exactly 6 o'clock. So I'll first take some questions, and then if some of you want to see the demo, I can show them, but let's take the questions first. Questions? Yes?
I saw there's another primary variable called library,
Yeah. The library primaries are libraries which are not handled by Libtool. So if I'm correct, those libraries can only be static libraries. Yes? To include specific make rules? Yeah, like if you need, for example, to generate at build time a file by running some weird program with some special arguments, then you will most likely need some custom make rules, which can be included. Makefile.am is really just a make file. So you can write blah, blah, colon, and then some rules. Of course, for that to integrate well with Automake, there are a bunch of rules to comply with. But you can write custom make code in addition to all the things that Automake generate. Yeah, there are some rules. I'm not a big, I don't know a lot about writing custom make code, But the Automake documentation has quite a lot of things. There are even hooks that you can attach, like if you want at make this time to do something more, or at make install time to do something more, you can attach some hooks to the installation process or this process and so on and so forth. So that's why I say I'm really only touching the surface of Automake and Autoconf here, but hopefully that's enough to go into the manuals and understand what's going on. Other questions? Are we all set? All right. Then the slides will be online, both on the conference website and at this location. I will add also in the slides the location of the GitHub repo where I've pushed all the demos. They are, of course, simple, stupid, but can still be useful to look together with the slides. So that will be all online. Thanks a lot to all of you for attending.